Okay, in this series we'll be looking at some ratios. Now, one of the most simple and somewhat common places we find ratios is when mixing cordial or something. So let's say we're mixing two different cups of cordial here. One in the ratio 1:4 and the other in the ratio 2:5. Okay, what these ratios do is they compare the amount of cordial and the amount of water in each mixture. Okay, so what does a ratio of 1:4 mean on the left there? Well, it means for each bit of cordial we use here, we're going to mix that with 4 bits of water, and of course, for the comparison to be fair, all the bits hold the same amount, they are of equal size. So another way to think about that would just be that there is, 4 times as much water as there is cordial, okay? What about the 2:5 on the right there? Again, it's comparing the amount of cordial and water used, so that ratio means when we compare those amounts, it's like cordial takes up 2 bits and water takes up 5 bits. So that expresses a different proportion, I guess a slightly stronger mixture of cordial. Now, of course, in reality, these two things would just be fully mixed together like that, and one important thing to know is that the ratios themselves tell us nothing about the actual amount of drink we've got. So we have these comparisons. The one on the left has 4 times as much water than it does cordial, while the one on the right uses a higher proportion of cordial, but just knowing the ratios doesn't say anything about the amount of stuff we're using. So we don't know whether this is like a 200ml cup or a 2-litre bottle or whatever. We don't know, and it doesn't matter, since the ratios are only there to compare the amounts, not to tell us how much there actually is. But while we're thinking about this total amount, it might be helpful to see the link between ratios and fractions, since you probably can tell from the picture they're quite closely related. On the left, we don't know how much stuff there is in the cup, but we do know that we can meaningfully split the mixture into 5 equal bits. So it makes sense to think about splitting into fractions out of 5. Then the cordial there would take up 1 bit out of the 5 bits, while the water there would take up the other 4 bits out of the 5 bits. Likewise with the one on the right, we don't know how much stuff there is in the cup, but we can meaningfully split that mixture into 7 equal bits. So it would make sense to think about splitting that one into fractions out of 7. And likewise the cordial there would take up 2 bits out of the 7 bits, while the water there would take up the other 5 bits out of the 7 bits. It works in very much the same way, okay? And so a main difference is this. While a ratio compares two quantities with each other, a fraction compares each separate part with the total amount. Okay, and so that's why there's a pretty big difference between ratios and fractions in terms of interpreting and applying them to practical contexts, even though mathematically they behave almost exactly the same way, and more on that in the next video. Okay, so how do we bring quantities and amounts into play? Let's just work with this 2:5 ratio here, and we'll see an example using this cup and this mixture. In general, we need to already know at least one thing, one amount. Whether that's the total, the amount of cordial, the amount of water, whatever it is, we need to know one amount. Okay, so say here, we can ask how much water we should mix with 50 ml of cordial. That's the amount we're going to use. The main idea then is to take this known value to work out how much each individual bit is worth. Once you know the size of each bit, everything else normally becomes easy. Okay, so how do we do that? Well, first, I'll redraw the bits the way I'd do it if I were writing this out on paper. I wouldn't be drawing a whole cup and everything so fancy. I'd just put 2 bits there like this, and 5 bits there like that. Then we're told that there are 50 ml of cordial, so that means these 2 red bits here are worth 50 ml. Again, the first goal is normally to work out how much each bit is worth. So we can divide the 50 by 2 to see that each bit is just 25 ml. Now remember, ratios are built to make a fair comparison. So even though I've color-coded the bits to represent the cordial and water, it's really a level playing field. All of the bits across the whole picture are the same size, meaning that they all hold 25 ml as well. So how much water do we need then? Well, the water is worth 5 of these bits, and each one holds 25 ml, so we can just do 25 times 5, and we get 125 mils. Okay, so that's how we play with these ratios. If we know some given quantity, once we work out how much each bit is worth, we can usually just multiply to see the amount we're looking for. Okay, so that's all for this one. Thanks for watching, and see you next time.